All right, let's dive into quantum superposition. It sounds super complicated, but it's actually kind of fundamental to everything around us.
Yeah, it really is.
We'll be using quantum computing for the quantum curious as our guide today.
Cool.
I'm really excited to see where this deep dive takes us with you.
I think a good place to start would be to define superposition in classical physics. The physics we experience day to day. Basically, it's just combining two things to create something new. Right?
So like if you mix blue and yellow paint, you get green.
That's a great example. The book gives us a couple more interesting ones. Imagine two waves that kind of come together, right? And depending on how they line up, they can either make a bigger wave or they can completely cancel each other out.
Oh, so is that how noise-canceling headphones work?
Exactly.
By creating a wave that like cancels out the noise you're trying to block.
Uh-huh. And there's tons of other examples. Think about if you're calculating the total force on an object, right?
Yeah.
If there's multiple forces pushing or pulling on it, you'd have to add those forces together to figure out the net effect.
Makes sense.
That's superposition too.
Okay, so adding forces, mixing colors, canceling out sound waves. These are all like pretty straightforward ways of combining things.
Yeah.
How does that translate to the quantum world?
That is where things get really interesting. In quantum mechanics, superposition means that things can be in multiple states at the same time.
Whoa.
It's not just that we don't know which state they're in. They're actually in all of those states at the same time until we measure them.
Wait, so it's kind of like a coin flipping through the air?
Yeah.
Like it's not heads or our tails, it's both at the same time until it lands.
Exactly. That's a perfect analogy. And actually, the book uses the same one. It's only when the coin lands, when we make a measurement, in a sense that it settles into a single state.
Oh, wow. Okay. So unlike classical physics, we're not just combining things here. We're saying something can exist in multiple states at once.
Yep.
Like it's defying the rules of like how we normally perceive reality.
Yeah. And to really wrap our heads around this, I think it's helpful to understand another crucial concept: energy quantization.
Okay, quantization. Does that mean like dividing a cake into equal slices?
Well, sort of. In the quantum world, energy levels are like stairs. You can only be on one step at a time, not in between.
Got it. So no half steps allowed in the quantum world.
Exactly.
But how does this relate to superposition?
Think of it this way. A quantum system can be in a superposition of multiple energy levels. Like it can be standing on multiple steps of the staircase at the same time.
Okay, so we're saying a quantum system can not only exist in multiple states, but it can occupy multiple energy levels at the same time.
Precisely.
Wow. That's a lot to wrap my head around.
It is.
But it's what makes quantum mechanics so fascinating, I guess.
Definitely. And to really see how bizarre this can get, I think we need to talk about Schrodinger's cat. So Schrodinger's cat, it's this thought experiment supposed to illustrate how weird quantum superposition can be,
Yeah.
But I always end up feeling kind of more confused than anything else.
Maybe we can, I don't know, maybe we can break it down together. What exactly is Schrodinger's cat, and how does it relate to everything we've been talking about?
Okay, so imagine this. There's a cat, right, inside a box. And in the box, there's this device. And it has a 50-50 chance of releasing poison. Deadly poison.
Okay.
The thing is, the release of this poison is tied to the state of a radioactive atom,
Okay.
which is in a quantum superposition.
So the atom's like both decayed and not decayed at the same time.
Right. And since the cat's life is linked to that atom, it means the cat is also in a superposition of states. It's both alive and dead until we open the box.
Whoa, okay, so opening the box is like making a measurement.
Yeah.
Like in that coin flip example, we're forcing the atom and the cat into one definite state. But what does it even mean to measure something in quantum mechanics?
Well, that's a question that physicists are still debating to this day. But basically, a measurement happens when a quantum system interacts with its environment in a way that, reveals information about its state. And as we've seen, that interaction causes the superposition to collapse.
That is so wild. Like the whole idea of observation affecting reality at the quantum level.
Yeah.
Makes me wonder if we can actually see quantum superposition happening in our everyday lives.
It's a great question. But, while quantum superposition is the bedrock of how things work at a microscopic level, it's not something we easily observe in the macroscopic world.
Right.
Like you think about a coffee cup, right? It's
Yeah.
made up of trillions of atoms, and all their individual quantum states, they kind of average out. And that leads to the classical behavior that we see.
It's like all those tiny quantum superpositions just get I don't know, drowned out in the crowd.
Yeah, exactly. But that doesn't mean that quantum superposition isn't T all around us. It's just happening at scales that are way too small for us to pick up on.
Okay, so I get that it's happening, but if we can't even see it, does it really matter? Like, what's the big deal about quantum superposition anyway?
This is where things get really exciting. While we might not be able to see quantum superposition directly, it has some pretty big implications for technology and our understanding of the universe. One area where this is becoming really clear is quantum computing.
Quantum computing, that sounds like something out of a sci-fi movie.
It does, but it's becoming more real every day. Quantum computers take advantage of superposition and other quantum phenomena to carry out calculations that are, like, impossible for even the most powerful classical computers. Like, imagine solving problems in minutes that would take, classical computers thousands of years.
Whoa, okay, so by tapping into these weird quantum rules, we can create super powerful computers. What kinds of problems could they solve?
That's the really exciting part. Quantum computers have the potential to revolutionize fields like medicine, material science, and artificial intelligence. Like, we could develop new drugs or design more efficient solar panels. We could even unlock the secrets of the human brain. It's really exciting.
Wow. So even though we can't see quantum superposition happening, it's driving the development of technologies that could, like, change the world.
Yeah.
It makes you wonder if there are, like, other examples of quantum superposition impacting our lives in ways we don't even realize.
Totally. Think about photosynthesis, how plants convert sunlight into energy.
Yeah.
It turns out that quantum superposition plays a crucial role in making that process incredibly efficient.
So something as fundamental as, like, life on Earth relies on these quantum principles.
Exactly. And there's more. Superconductivity, where materials conduct electricity with zero resistance, is another phenomenon that we're beginning to understand through the lens of quantum superposition.
Man, I'm starting to grasp, like, the enormity of this. It's like this invisible force that's woven into the fabric of reality, influencing everything from the tiniest particles to, like, the way life itself functions.
Yeah, it really is. And it's a good reminder that there's still so much that we don't know about the universe. Speaking of mysteries, remember that coin flip analogy?
Yeah.
Well, Einstein famously questioned the implications of quantum mechanics by asking, if we don't observe the moon, does it really exist?
Wait, so is he suggesting that the moon is in this giant superposition until someone looks at it? So is he saying the moon, like, only exists when we look at it?
Well, it's a little more nuanced than that. Einstein was really grappling with the philosophical implications of quantum mechanics, particularly the role of observation.
Right.
Like, does something actually have to be observed to exist? Or does reality exist independently of, our perception? It's a question that's, like, still being debated by physicists today.
It really makes you wonder about the nature of reality, doesn't it?
Yeah.
So much of what we've talked about just seems to challenge our everyday understanding of, like, how the world works.
It does.
Yeah.
It really does.
It's so weird.
Quantum mechanics is full of these mind-bending ideas that, they just contradict our common sense. But the thing is, it's been proven time and time again through experiments.
Yeah, it's incredible to think that something so strange and, like, so counterintuitive is actually the foundation of our universe. Like, we started by talking about superposition in classical physics, you know, like waves combining, canceling each other out.
Mm-hmm.
And then we went, like, deep into the quantum world where things can exist in multiple states at once until we measure them.
Right, and that coin analogy, I think, really helped to illustrate that.
Definitely. It's both heads and tails until it lands.
Exactly.
And then we talked about energy quantization and how a quantum system can occupy multiple energy levels at the same time, like standing on multiple steps of a staircase at the same time.
Yeah, that's a great way to think about it.
Right. And then there's, like, Schrodinger's cat, both dead and alive until we open the box.
Yeah.
Ugh, it's just so bizarre.
It's so bizarre and so fascinating.
Yeah.
And it really highlights how much we still don't know, right? Like, we've only just begun to really scratch the surface of understanding the quantum world.
Well, for one, I am definitely hooked. I need to learn more about these quantum computers and all the amazing things they could do.
There's so much to explore, like, quantum cryptography, quantum teleportation. These are all, like, real areas of research with incredible potential. And who knows what other applications we'll discover as we continue to, kind of unravel the mysteries of quantum superposition.
This has been such an incredible deep dive. I'm leaving with more questions than answers, but I'm definitely feeling a lot more curious about like the hidden workings of the universe.
It's been my pleasure. And remember, even if it seems strange and counterintuitive, the quantum world is always there, humming along, whether we observe it or not.
And on that note, I think we'll wrap things up here. Until next time, keep exploring and stay curious.